Let us continue. MPV reduction, Mervin-Pondorf-Verley reduction. In the Mervin-Pondorf-Verley reduction, let us take carbonyl compound. Then isopropyl alcohol will take. Then aluminum isopropoxide. Aluminum isopropoxide will take. Aluminum isopropoxide we are taking. This ketone is converting into alcohol. This isopropyl alcohol is converting into ketone. Sir, what is the mechanism involved in it? That we will see. Now we will take this ketone. We are taking. This aluminum isopropoxide we will take. Okay. So we are taking aluminum isopropoxide. It is one isopropoxide. Remaining isopropoxide we will write. Remaining isopropoxide we have written. This is 2 times. Remaining 2 times we have written. Okay. Now, how the chemical equation takes place, that we will see. Now, here what happens means, this CH bond is making bond with this carbon. This CO bond is going like this. It is making bond with aluminum. This bond is going like this. Okay. Now we will give transition state. We will give the transition state here. Now this CO bond, we will give single bond. We will give this CH bond is there, and this CO bond is there. That aluminum is there. Here the 2 methyl groups we will write. Here the single bond we will write. Here that isopropoxide we will write here. Here isopropoxide how many times means 2 times isopropoxide that we have written. Sir. Now what happens means, here bond is breaking partially, here bond is producing partially, here bond is breaking partially, here bond is producing partially, here bond is breaking partially, here bond is producing partially. Like this transition state we are getting. Okay, like this transition state. Okay, next step. What happens means, here bond breaks completely. Okay, here bond breaks completely. This bond is breaking completely. So this is detaching as acetone. That is detaching as acetone. Okay. So what is the rest? The 2 R groups, carbon, here hydrogen is formed, hydrogen, here single bond O, single bond Al, here isopropoxide 2 times. Okay, like this we got it. So next step, what we will see. Here we have taken this isopropyl alcohol. We have taken that isopropyl alcohol we will take. We will take now. So we will take isopropyl alcohol. We have taken isopropyl alcohol. Okay. So what is happening now? How the reaction takes place, that we'll see. This lone pair attacking this aluminum. This lone pair is attacking this aluminum. Okay. So what will happen? That point we'll see. So this R, CH, here O, here aluminum will be there. Here aluminum O. This is isopropoxide 2 times. Now which is making bond means isopropyl alcohol is making bond. So OH, here positive charge will be there for oxygen. Okay. So what is the next step takes place, that you see that now aluminum gets a negative charge. So what is the next step? We'll see. This bond will migrate. This bond will migrate. This will attack this H. Okay. So what is leaving? Now this is aluminum isopropoxide is leaving. Okay, this is becoming what in the sense R CHOH. Okay, therefore, what we have taken CO ketone we have taken, we got alcohol. Ketone has been converted into alcohol. Isopropyl alcohol has been converted into what in the sense acetone. This aluminum tertiary aluminum isopropoxide is catalyst that is reproduced. Aluminum isopropoxide is the catalyst that is reproduced. So what how the atoms are replacing, that we will see. In the carbonyl group, this carbon becomes CH. In the carbonyl group, this carbonyl group carbon becomes CH in the product. This carbonyl group carbon gets hydrogen from where? This is catalyst. Aluminum isopropoxide is the catalyst. In the isopropoxide, this CH, this hydrogen goes to carbonyl group carbon. This is aluminum isopropoxide catalyst. In this, it is isopropoxide. This CH, in this CH, this hydrogen goes to carbonyl carbon. Okay, so this carbonyl group carbon gets hydrogen from where, means from catalyst, that isopropoxide. This CH is giving hydrogen. Okay, suppose here instead of H, here deuterium is there, means at this place what would be there, means deuterium would be there. Okay, so the carbonyl group carbon gets hydrogen from catalyst, that isopropoxide, this carbon is having hydrogen, that hydrogen, if it is having deuterium, that deuterium will come here. Okay, then this carbonyl group oxygen becoming OH. This hydrogen from where? This hydrogen from where, means it is isopropyl alcohol. This is the solvent. This solvent isopropyl alcohol is making bond with aluminum here. Making bond with aluminum here. That solvent isopropyl alcohol OH group oxygen made bond with aluminum. That OH group hydrogen goes to this oxygen. Goes to this oxygen. So this oxygen, this carbonyl group oxygen gets hydrogen from where, means solvent isopropyl alcohol OH group hydrogen comes to this place. If here instead of H deuterium is there, means here deuterium would be there. Correct? Then here what is leaving, in the sense acetone is leaving. From where we are getting this acetone? From where we are getting this acetone, in the sense it is a catalyst. This is aluminum isopropoxide is a catalyst. That catalyst made a transition state with this carbonyl group. From this acetone is leaving. From this acetone left. So this acetone we got from this catalyst, aluminum isopropoxide. This acetone we got from this aluminum isopropoxide. If Me2, in this Me2, if CD, this Me, if it is existing as CD3, then here CD3 will be there. Okay, so this acetone from where we are getting? From aluminum isopropoxide we are getting. Okay, then what happened to this solvent? This solvent oxygen made a bond with aluminum. See that this is the solvent. Isopropyl alcohol is the solvent. This solvent oxygen making a bond with aluminum. See, solvent oxygen making bond with aluminum and leaving as aluminum isopropoxide. Okay, so this is what, in the sense, MPV reduction. In MPV reduction, Mervin-Pondroff-Verley reduction, this carbonyl group is converting into what, in the sense, alcohol. Carbonyl group is converting into alcohol. Here catalyst is aluminum isopropoxide, solvent is isopropyl alcohol. It is converting aldehyde into alcohol, ketone into alcohol. It is not affecting CC double bond. It is not affecting CC triple bond. Okay. So this is not affecting CC double bond and not affecting CC triple bond. Okay. Now let us see MPV reduction continuation. MPV reduction continuation we will see. Now we will take the substance, what in the sense, acrolein. We are taking the substance acrolein, we will take. This acrolein on taken to MPV reduction, what happens, means aldehyde is converting into primary alcohol, that is CH2OH. This aldehyde carbon, it is that carbon is converting into CH2OH. Aldehyde CHO is converting into, this CHO is converting into CH2OH. Okay, this CC double bond is not affected. CC double bond is not affected here. Okay, next we will take next compound we will take so and so. This compound is called what in the sense crotonaldehyde. This compound is called crotonaldehyde. This compound is called what in the sense crotonaldehyde we can say. Here what we can say in the sense this aldehyde CHO group is converting into CH2OH. Aldehyde CHO is converting into CH2OH in MPV reduction. CC double bond is not affected. This compound is called crotyl alcohol. This compound is called crotyl alcohol. We are getting crotyl alcohol. We are getting. So, next naming reaction we'll see. Next naming reaction is Clemmensen reduction. So, next naming reaction is what means Clemmensen's reduction. So, next one is Clemmensen's reduction. We'll see. In the Clemmensen's reduction, what is a reagent in the sense zinc amalgam and corn HCl? Zinc amalgam and corn HCl is the reducing agent. Clemmensen reduction reagent is zinc amalgam. Amalgam in the sense mercury is there. Zinc amalgam plus concentrated HCl. Okay. This Clemmensen reduction, what it will do in the sense carbonyl group will be converted into methylene group. Carbonyl group will be converted into methylene group. Carbonyl group is converting into methylene group CH2. Okay, in this Clemmensen reduction. It is not affecting CC double bond. It is not affecting CC triple bond. CC double bond, CC triple bond are not affected by this reagent. Then if alcoholic group is there by this reagent, what happens means alcoholic group can undergo dehydration. Why? Because acid is there. HCl, concentrated HCl is there, acid is there. Therefore, alcoholic group can undergo dehydration. This is about Clemmensen reduction. Okay, now we will see. We will see about Clemmensen reduction. We will take carbonyl compound. We have taken carbonyl compound. On Clemmensen reduction, what happens means carbonyl carbon becomes methylene. Carbonyl CO group becomes CH2 group. So, what is the mechanism involved in this? That we will see. H plus acid is attacking this. Acid is attacking. Therefore, this oxygen is getting becoming hydronium ion. Okay, oxygen becoming hydronium ion. Next, what happens means next zinc comes and donates 2 electrons. Then zinc becomes Zn2 plus. The 2 electrons attacking this carbon, pi bond is migrating to oxygen. Therefore, carbon is having 2 electrons now. Therefore, negative charge, a single bond OH, here R. So, like this is there. Now, this C minus, if this C minus takes H plus, C minus is taking H plus. Similarly, this oxygen also taking H plus. C minus is taking H plus, oxygen also taking H plus because acidic medium is there. C minus taking H plus, therefore CH, oxygen taking H plus, therefore oxygen is getting positive charge. Okay. So next step we'll see zinc and zinc is coming and donating 2 electrons. Zinc becomes Zn2 plus. The 2 electrons attacking carbon. This water is leaving. Therefore, we are getting C minus here or water is leaving here. Water is leaving. Now this C minus, okay, here already one nitrogen is there, that nitrogen will write, okay. Now this C minus take H plus from the acid and becomes what means RCH2R, okay. Therefore, carbonyl group becomes methylene group, we can say. Carbonyl group CO becomes methylene group CH2. That's what we can say. That is happening in this reaction. It is about Clemmensen reduction. Now we will take example for some example for Clemmensen reduction. We'll take so and so we have taken here. Clemmensen reduction in the sense CO group is converting into CH2 group. Then double bond is not affected. Double bond is not affected. Therefore, it is the product. Next, we'll take. Next, we'll take here. Here double bond O will take. Here OH will take. What is the product we'll get? We'll see. Here how many carbon atoms means 2, 4, 6. 6 carbon atoms are there. 2, 4, 6. 6 carbon atoms are there. The carbonyl group is converting into methylene group. Okay. Now here OH group is there. This OH group undergoes dehydration. This OH group is undergoing dehydration like this. Therefore, water is leaving, pi bond you are getting here. Okay, it is undergoing dehydration. If OH group is there, then dehydration is possible because acidic medium is available. Dehydration is possible here, we can say. Okay. Then why can't dehydration this side? This side means here also double bond you will get, but this double bond means it is more stable because highly substituted alkene will be major product. Therefore, this is a major product, we can say. Don't give double bond here, that is minor product. Okay, this is the product, we can say. Sir, next reaction will take. Now we will take this reactant, this on Clemmensen reduction. What is the product means? This is the product. Clemmensen reduction gives this product. Carbonyl group converts into methylene group. Carbonyl group is converting into methylene group, and even CC double bond also converting into single bond here. CC double bond also converted into single bond. Why? Why? Because this carbon is directly attached to carbonyl carbon, therefore alpha carbon, it is beta carbon. Alpha beta olefinic bond is undergoing reduction in Clemmensen reduction. Alpha beta olefinic bond. Alpha beta olefinic means that pi bond. Alpha beta olefinic bond is converted into single bond in Clemmensen reduction. So what about the Clemmensen reduction we have discussed? Next we will go for a next naming reaction, that is called Wolff-Kishner reduction. Wolff-Kishner reduction will take. Wolff-Kishner reduction we are taking. In this, what is a reductant means? What is a reducing agent? Reducing agent is hydrogen plus a strong base. Hydrogen plus strong base. What is the strong base means? Potassium hydroxide we can use. Otherwise, tertiary butoxide you can use. Tertiary butoxide. Tertiary butoxide we are using. Then we are taking solvent. Solvent is what in the sense glycol. Glycol is a solvent. Then what is the temperature we have to provide in the sense 453 to 473 Kelvin we have to provide. 453 to 473 Kelvin we are providing. What is the reaction? We'll see. Here carbonyl compound is converting into, carbonyl group is converting into methylene group. Carbonyl group is converting into methylene group here. Carbonyl group CO. Carbonyl group is converting into methylene group here. Sir, what is the mechanism involved, that we'll see. Now we will take a carbonyl group. We are taking carbonyl group. Hydrogen we will take. We are taking hydrogen. Okay. Now you know that carbonyl group and hydrogen is there means nucleophilic addition come elimination of water possible. Therefore, nucleophilic addition come elimination of water we will write. Therefore, we will round off water molecule. So water molecule is leaving. Therefore, we are getting what in the sense double bond N NH2. This is called what in the sense hydrazone. This is called hydrazone, we can say. Now here what is a medium means basic medium. So basic medium we will take. Basic medium means OH minus. Now this OH minus is abstracting this proton. OH minus is abstracting proton. Okay. OH minus is abstracting proton. Therefore, this bond pair is converting into lone pair. So we are getting RCR double bond N, here lone pair, single bond N, two lone pairs, negative charge H. Then what happens means this lone pair is shifting to pi bond, this pi bond shifting as lone pair. So we are getting RCR, carbon is having lone pair negative charge, then single bond N, nitrogen, between nitrogen double bond is there and one nitrogen is there. Next OH minus comes again. This OH minus is abstracting proton. It is abstracting proton now. It is abstracting proton and become water. This is leave. It is becoming lone pair. It is converting. It is going here. Okay, that is going there. Okay. So what we will get, that we will see. Okay. And also here what is happening means H plus abstraction will be there first. Before going to this step, the C minus we will complete. Okay, C minus case will complete. Now here H will be there. This C minus takes H plus from water. Water becomes OH minus. Therefore, RCH or N double bond NH, like this we'll write. Okay, the C minus takes H plus from water. Okay, that step we have written. C minus takes H plus from water. Next step, OH minus takes H plus. OH minus takes H plus. This bond pair shifting here as a lone pair. So we are getting negative charge here. Okay. So OH minus takes proton and becomes water. Therefore, here we will write so and so we'll write. Here nitrogen is having lone pair. Here two lone pairs will be there. Negative charge will be there. Let us see next step. What is the next step in the sense this lone pair becomes pi bond. This bond is shifting. Therefore, N2 is leaving. So what we are getting in the sense we are getting so and so carbon is having lone pair and negative charge. The C minus takes H plus from water. Therefore, H plus H2O becomes OH minus and leaving. So we are getting RCH2R. Okay. Therefore, we can say the carbonyl group is converting into methylene group. We can say carbonyl group is converting into methylene group. In this case, carbonyl group is converting into methylene group. So Wolff-Kishner reduction means carbonyl group is converting into methylene group. We can say okay. Next reducing agent we'll see. Next reducing agent is what means red phosphorus and HI. Red phosphorus and HI, hydrogen iodide. Red phosphorus and hydrogen iodide is a reducing agent. Here also, in this reducing agent also, carbonyl group is converting into methylene group. Carbonyl group is converting into methylene group, we can say. Acetaldehyde will take, this acetaldehyde is converting into what in the sense ethane. This acetaldehyde is converting into ethane. In the red phosphorus and hydrogen iodide reducing agent, if we take, aldehyde is converting into, the CO group is converting into methylene group. Okay, ethane we are getting, HI is converting into I2. What is the temperature required in the sense 423 Kelvin. Next, we will take acetone. We are taking acetone. Here, carbonyl group is converting into methylene group. Carbonyl group is converting into what in the sense methylene group, we can say. Next reducing agent we will take. Next reducing agent is what means magnesium amalgam and water. Next reducing agent is what? Next reducing agent what means magnesium amalgam and water. Okay. Next reducing agent what means magnesium amalgam and water. Okay. Now we will take ketone. That means we will take carbonyl group. Okay. This is reacting with the magnesium. It is reacting with the magnesium. Magnesium is providing 2 electrons. Magnesium is providing 2 electrons. Okay. Magnesium is providing 2 electrons and becomes Mg2 plus. Mg2 plus. So what happens that we will see. Okay. Now we will take carbonyl group 2 times. Carbonyl group 2 times we will take. Here what happens means here 2 electrons present in this bond. 2 electrons present. This bond is breaking partially. This bond is breaking homolytically. Here also bond is breaking homolytically. One electron is given to this oxygen, another electron given to this oxygen. Okay. Therefore, we are getting what we will see RCR. Carbon is having one electron, oxygen is having negative charge because oxygen is gaining one electron from magnesium. Another ketone will take, carbon is having one electron, oxygen is having negative charge. To satisfy this negative charge, Mg2 plus is there. Okay. So next what happens in the sense this O minus takes H plus from water. O minus takes H plus from water. Therefore, water becomes OH minus. Another water molecule takes another water molecule from that. This O minus takes H plus. That is also becoming OH minus and leaving. Mg2 plus takes 2 OH minus and becomes MgOH twice. MgOH twice. Okay. Now between this CC, between the C dots, what is formed in the sense single bond is formed. Between C dots, a single bond is formed. Here this O minus becomes OH, this O minus becomes OH. Okay, we are getting a like this vicinal diol we are getting. What is a reducing agent means magnesium amalgam and water. Reducing agent we have taken a what in the sense magnesium amalgam and water we have taken. Okay. Next naming reaction we will see. Next naming reaction what in the sense aldol condensation. We are going for what in the sense aldol condensation. Aldol condensation. For aldol condensation, what we have to take in the sense carbonyl compound we have to take. We have to take carbonyl compound. And here at least one alpha hydrogen must be present. at least one alpha hydrogen must be present. Then only aldol condensation is possible. What reagent we have to take means dilute alkali we have to take. We have to take dilute alkali. Okay. So aldol condensation means carbonyl compound we have to take. This carbonyl compound must contain at least one alpha hydrogen. Okay, at least one alpha hydrogen should be there. Then dilute alkali should be there. Dilute alkali must be there. Dilute alkali must be there. Then only we will get aldol. Okay. Now we will take carbonyl compound, for example, acetaldehyde. Okay, it is carbonyl compound. Okay. Here alpha hydrogen is there or not, we must check. Alpha hydrogen. Okay. Alpha hydrogen, at least one should be there. At least one alpha hydrogen should be there. Okay. At least one alpha hydrogen should be there. It is carbonyl carbon. It is carbonyl group. This carbon is directly attached to carbonyl carbon. This carbon is directly attached to carbonyl carbon. Therefore, this carbon is called alpha carbon. This alpha carbon is having hydrogen. Therefore, this is having alpha hydrogen, we can say. In this carbonyl group, in this carbonyl compound, 3 alpha hydrogens are there. Actually, condition is what? At least one alpha hydrogen. Therefore, more than one is there. Therefore, no problem. Okay. Then, what is the medium we are providing in the sense? Dilute alkali. Dilute alkali we are providing. That means OH minus we are providing. Dilute alkali we have to provide. Dilute alkali we are providing. Okay. So what happens means this OH minus is abstracting alpha hydrogen and becoming water. This bond is going towards carbon, therefore carbon is getting lone pair. Carbon is getting lone pair, therefore carbon is having negative charge, therefore this carbon is called carbanion. This carbon we can call it as carbanion. So intermediate is carbanion here. So what is the intermediate means? Carbanion is the intermediate. This carbanion is attacking another carbonyl carbon. It is attacking another carbonyl carbon. So we'll take another acetaldehyde. Okay. So what happens means this carbonyl carbon, this carbanion C minus attacking carbonyl carbon. Okay. The bond is migrating like this. This carbanion carbon is attacking carbonyl carbon. So this bond is migrating towards O. Okay. So what we are getting in the sense this aldehyde group, we can take, this CH2 group we can take, then this carbon is making bond with this carbon we can say. Okay, then this is becoming O minus we can say, and H, this CH3 is there, okay, then this O minus takes H plus from water. This O minus is taking H plus from water. This O minus taking H plus from water, water becomes OH minus. Therefore, what is there means this CHO, here CH2, here CH2, this is CH, this O minus becomes OH, this side CH3, this side CH3. Now here if you see, here aldehyde functional group is there. From aldehyde, first 3 letters we will take ald. Then alcohol functional group is there. For alcohol functional group, suffix is OL. That OL we have written. Therefore, it is called aldol. So name what aldol is there. Why is it so? We got idea. What is the name condensation? Condensation given why? This carbanion carbon, carbonyl group carbon, between them bond is produced. Okay. Carbanion carbon, carbonyl group carbon, between them bond is produced. Therefore, condensation we can say. Okay. Next we will see. Next step what happens means, if you heat this content, if you warm the content, if you warm this aldol, what happens means, like this possible, water is eliminating. So what we are getting in the sense, here CHO, here CH double bond CH3, like this we will get. That means here double bond is formed. Elimination of water is possible. Pi bond is produced. This is alpha carbon, it is beta carbon. Therefore, alpha beta unsaturated. Pi bond is there. Therefore, unsaturated. Unsaturated carbonyl compound, we have to say. It is alpha beta unsaturated. Why unsaturated? Pi bond is there. Okay, unsaturated carbonyl compound. Carbonyl means here aldehyde group is there. Therefore, carbonyl compound, we have to say. Okay. So this is a product in aldol condensation. The name of this compound is what in the sense? Crotonaldehyde. The name of this compound is crotonaldehyde, we can say. Okay, so what is aldol condensation? We got idea. So aldol condensation means we have to take carbonyl group that must have at least one alpha hydrogen. More than one alpha hydrogen means no problem. No alpha hydrogen means aldol condensation never possible. Why alpha hydrogen is required? What is the necessity of at least one alpha hydrogen? Here alpha hydrogen is there, therefore OH minus is abstracting this proton, therefore carbanion is produced. That carbanion is attacking another carbonyl compound carbon. Another carbonyl group carbon it is attacking. This carbanion carbon, this C minus is attacking carbonyl group carbon. Okay, therefore condensation. So if alpha hydrogen is not there, if suppose beta hydrogen is there, no alpha hydrogen, if beta hydrogen is there, means is it possible or not? If beta hydrogen is having sufficient acidic nature like alpha hydrogen, then possible. Otherwise, no. For that case, electron withdrawing groups is there means then possible. Okay. Otherwise, no. Only aldehyde is there, and then CH2, CH3 like this is there means then we should not consider. Okay. Sir, alpha hydrogen is required, we said. Okay. Why only one alpha hydrogen? Why only one alpha hydrogen they are asking? Because only one H plus is abstracted. Therefore, only one alpha hydrogen. Okay. Then what is the necessity of dilute alkali reagent? Because this alkali OH minus is abstracting alpha hydrogen. Alpha hydrogen, it is abstracting proton, therefore. Okay, sir. Now, here carbonyl group also is having hydrogen. OH minus is not abstracting that H. Why? Because it is reducing hydrogen, whereas it is acidic hydrogen. Therefore, okay, sir. Next, we will see aldol condensation continuation. We will see. Now we will take acetone. This acetone is having can it go for aldol condensation or not? We will see. Now acetone we will write structural formula. We will write structural formula. We have written like this for acetone. It is a carbonyl compound. It is alpha carbon because this carbon is directly attached to carbonyl carbon. It is alpha hydrogen. It is alpha carbon. This is alpha hydrogen. So alpha hydrogen is there. So we will add dilute alkali. This dilute alkali, what it does means it is subtracting proton. This dilute alkali means it is subtracting proton. It is subtracting. This bond is shifting. Therefore, we are getting carbanion. So CH3, CO, CH2 minus, CH2 minus. Okay, carbanion we are getting. We got a carbanion. This carbanion is attacking another acetone, another carbonyl group. This carbanion is attacking another carbonyl compound. So C minus is attacking this C. So this pi bond is shifting to this O. Okay. This C minus carbon. This C minus is attacking this carbonyl carbon. Therefore, pi bond is shifting to this O. So what we will get, we will see CH3, CO, this CH2, CH2, here CO, so O becomes O minus, two CH3 groups we will write. Okay. This O minus is abstracting proton from water, therefore water becomes OH minus. Now CH3CO, this is CH2, here COH, here CH3, here CH3. Okay. Next, it is on warming. It is on warming. What happens means this is a aldol. This is also aldol, we can say. But here ketone is there. How to say aldol means? Otherwise, we can say it is ketol. Ketone first three letters we can say ketone first letters three letters we have taken. Ketone first three letters we have taken. Alcohol suffix ol we will write. Ketol also we can say. Okay, but this ketol, this A and O difference is there. This is there means cyclic ketol where we have seen acetal ketol we have seen no that alcohol the aldehyde is reacting with alcohol to give acetal ketol that is protecting carbonyl compound that we have seen no that place. This is different. Okay, this is different and this is different. Sorry, okay. So in aldol condensation, we got like this product we got. Next on warming, what happens means elimination of water. Therefore, this bond is shifting here. This bond is shifting here. Water is leaving. So we are getting a CH3, CO, CH double bond, C, CH3, CH3 we are getting. This is carbonyl group. This is alpha carbon, it is beta carbon. So we can say alpha beta unsaturated carbonyl compound, we can say. Alpha beta unsaturated carbonyl compound we got here, that we can say. Okay. This is about aldol condensation cell. Now we'll go for a aldol condensation continuation we'll do. Now we will take acetaldehyde, we'll take acetaldehyde. Then we will take a propione aldehyde. We are taking propione aldehyde. We are taking now dilute sodium hydroxide solution. Will take dilute sodium hydroxide solution. Dilute sodium hydroxide solution. Acetaldehyde we have taken. Propione aldehyde we have taken. Dilute sodium hydroxide solution we have taken. Now what happens? What is the aldol condensation? We'll see. First, we will convert, we will get carbanion. Now it is aldehydic carbon. This carbon is directly attached to aldehydic carbon. Therefore, it is alpha carbon. So this is alpha hydrogen. This hydrogen will remove this carbon. We will make it as carbanion. Okay. So we got carbanion now. We got carbanion. Okay. Now what is the next step? This carbanion will attack carbonyl carbon. Okay. Which is a carbonyl carbon? One possibility, another acetaldehyde. Another acetaldehyde is the one possibility. Okay. So now this carbanion is attacking this carbonyl carbon. So now we will write this CH2 I will write. Okay. This CH2 I will write. Then this CH I will write. This O I will make it as OH. This CH3 I will write. Okay. This is the aldol possible. If you warm the content, what will happen? This will convert into alpha beta unsaturated carbonyl compound. Okay, so next, this carbanion can attack propionaldehyde carbonyl carbon also no. Therefore, we will take propionaldehyde. We will take propionaldehyde. Okay, so now we will say this carbanion C minus is attacking propionaldehyde carbonyl carbon. This is shifting like this. Okay. Now what is the product? We'll see. This CHO will write. This CH2 will write. Then this CH will write. This O becomes OH will write. This CH2 CH3 will write. Okay. This is one product. Here you can make, if you warm this, it will go for elimination of water. Therefore, pi bond will come here. That is alpha beta unsaturated. Why pi bond should come here? Why can't here? Like that also you may ask. If pi bond comes here, this pi bond will be in conjugation with the carbonyl pi bond. But here means no conjugation. Therefore, pi bond will come here. Okay, sir. Then here we said carbanion formation from acetaldehyde. Is propionaldehyde can form carbanion? That possibility we'll see. Okay. This propionaldehyde is having alpha carbon. This carbon is directly attached to aldehydic carbon. Therefore, it is alpha carbon. This alpha carbon is having hydrogen. Therefore, it is called alpha hydrogen. This alpha carbon is converting into carbanion. That possibility is there. Okay. So, alpha carbon is converting into carbanion. That possibility we have written. Okay. So this carbanion can attack which one? One possibility, attacking this acetaldehyde. It is one possibility, isn't it? So it can attack this acetaldehyde carbon. It is one possibility. So what is the product? That we will see. This CHO will write. This CH we will write. This CH3 will write. Okay. Then that CH3 we have written. So we will write this CH3. Then this carbanion carbon is making bond with carbonyl carbon. Okay, that's CH. This O becomes OH. Then this is CH3. Okay, this is a product possible. Okay, so this is also aldol. This on warming gives alpha beta unsaturated carbonyl compound. That means this single bond becomes a double bond. Okay. Next, this carbanion can attack propionaldehyde carbonyl carbon, isn't it? That is also one possible, no? So it is attacking propionaldehyde carbon. So what is the possibility? Now this CHO, this CH, this CH3, this CH3, here single bond with this CH, OH, CH2, CH3. Now, this is formed by two propionaldehydes, therefore it is simple aldol. This is formed by one acetaldehyde, two acetaldehyde, therefore it is formed by propionaldehyde carbanion and acetaldehyde, therefore it is cross aldol, cross aldol. This is formed by one acetaldehyde and propionaldehyde, therefore it is cross aldol. It is formed from two acetaldehyde, therefore it is simple aldol. Simple aldol. So on taking mixture of aldehydes, we are getting this many possibilities. This condenses